Good morning, dear students. So as in the previous video we have seen the questions. I explained you the questions and I got a very good response from your side, but also not satisfactory from other students. Okay, so hereby I again inform you that if you won't see from the starting, then you won't get any of the topic or concept. Okay, so because I will be touching each and every topic of the exercise and each and everything, so I need your cooperation also to understand. Okay, so let us start with the question of the same exercise, but further, as in there are somewhere 35 questions in the exercise, and we will be seeing and there are that means variety in the questions, and we will see each and every variety, because this exercise is really very important, because from this exercise only the questions will be asked from this trigonometry. Okay, so focus here. Say for example, if this is the question, if 8x is equal to pi, then show that cos 7x plus cos x is equal to 0. Look wise, this question is so short, and solution wise also it is very short. Okay, 8x is equal to pi given, and this they are trying to ask 7x. So see how I am writing this. 8x is equal to pi s. Can we write this 8x as 7x plus x equal to pi? Take x that side, so 7x will be equal to pi minus x. So in place of 7x we can put pi minus x. So cos pi minus x plus cos x, we are taking LHS first. What is cos 180 minus theta? So 180 minus theta, first of all the function won't change, so cos will be cos, and in 180 minus theta means the second quadrant, only sine and cosec are positive. So cos is the question, so cos is not there in the quadrant, so we are going to use the minus sign. And what is the theta? This is x plus cos x. These two will be cancelling and will get 0 as the answer. Okay, so this is the question. Tan 25 degree is equal to x, and we need to prove that tan 155 minus tan 115 upon 1 plus tan 155 tan 115 is equal to 1 minus x square upon 2x. Now you would be thinking that here we can use tan a minus b identity. What is that tan a minus b identity? Is it tan a minus tan b upon 1 minus tan a tan b? And here this is the expanded form, so tan a minus b. What will be a minus b? That is 115 minus 115. So 115 minus 115 will give you tan 40 degree, and we don't have such 40 degree in our question. Instead we have tan 25 is equal to x. That means this process will go wrong for us. So what we are doing here, we need 25, we need tan 25 here in the solution. Then after on that tan 25 we'll put the value x, and then we'll solve it. But here we need to manipulate. How? See this tan 155, this 155 you can write it as 180 minus 25, you will get 155. Similarly for this tan 115 you can write 90 plus 25. Are you understanding why I'm doing like this? Because I have only tan 25, so related to that 25 I need to change this one and this one. So 155 is changed as 180 minus 25, and 115 is changed as 90 plus 25. Okay, and similarly in the downside, as it is. Now what is tan 180 minus theta? First of all the function won't change, so tan 25 as it is. 180 minus theta, this is the second quadrant, and in this only sign positive, so negative, minus 90 plus theta, the function will change to cot theta, cot 25, and 90 plus theta is this is the second quadrant, so only sign, so here cot, so minus. Okay, whole upon 1 plus. So whatever we have done, the same will be here also, and tan 25 minus. Okay, now this minus minus will be what? Positive. Tan 25 and sorry, this will be cot. Wait, this will be cot. Sorry. Minus minus will be what? Plus. Tan 25 and cot 25 will give you how much? 1 only. Okay, so here 1. Then this tan 25, we can write this cot 25 minus tan 25, rearranging it upon 2. Tan 25 can be written as 1 upon, sorry, cot 25 can be written as 1 upon tan 25 minus tan 25 whole upon 2. Okay, then take the LCM. Tan 25 into tan 25 will be 10 square 25 upon 2 10. Now you have tan 25 as x, so 1 minus x square upon 2x, hence proved. So like this we have to do this. Okay, say for example we have this question which says if A, B and C are angles of a triangle, then prove that tan B plus C plus tan C plus A plus tan A plus B upon this equal to 1 we have to prove. So as by the angle sum property A plus B plus C is equal to 180 degree, so for A plus B take C that side, so it will be 180 minus C. Also if you put B plus C here, take A there, so 180 minus A and C plus A is equal to 180 minus B. Now you substitute the values, that is tan B plus C is what? Pi minus A, that is 180 only, pi is what? 180 plus tan C plus A is what? 180 minus B, that is pi minus B, and tan of A plus B is what? Pi minus C upon tan pi minus A plus tan 2 pi minus B plus tan 3 pi minus C. Now as we can see that the whole numerator can be cancelled with the denominator, and I think you would be thinking that how we can cancel numerator by denominator. It is pi, here 2 pi. See, this is same, but here pi, here 2 pi, here pi with 3 pi. So let me tell you, this is 180. Okay, you just change it. 180 minus A, 180 minus theta tan, 180 minus theta you write here, then this also here also you write, and just check whether the all numerator and denominator they are cancelling, and we are finally getting 1. So after this you try to do this one. Okay, similarly if you see this question where ABCD are the angle of quadrilateral, then we need to prove this is equal to 0. So A plus B plus C plus D is equal to 360 degree, the 4 angles sum, and B, you keep B plus D here. That means you required B plus C plus D, keep here, take A that side. So what? 360 minus A. In case of this you put 360 minus A, and this is what? Minus of sin A. They both cancelled each other and you got 0 as the answer. Okay, let us come to this evaluation questions. Cos 105 plus sin 105, we have to evaluate this question. So how we are writing this 105? We are writing it as 60 plus 45, and here also 60 plus 45. Now we know that sin x plus y says sin x cos y plus cos x sin y, and cos x plus y says cos x cos y minus sin x sin y. So you can use cos x plus y identity here, cos x cos y minus sin x sin y, that is cos 60 cos 45 minus sin 60 sin 45, plus here sin x plus y identity, sin 60 cos 45 plus cos 60 sin 45. Putting all the values you can get the answer. So I have put all the values here. Alright, so as we can see that here this is cancelling with this one, and they both are getting added. So this is 1 upon 2 root 2 plus 1 upon 2 root 2. Okay, so here 2 upon 2 root 2. So 2 to 2 you can cancel, so 1 upon root 2 will be the final answer. Okay, similarly if you see the question, sin 70 cos 10 minus cos 70 sin 10 equal to root 3 upon 2 we have to prove. So we can use sin A cos B minus cos A sin B equal to sin A minus B identity. Okay, this is sin 70. Okay, so sin 70 minus 10. Okay, we have used the identity sin A cos B minus cos A sin B, which is sin A minus B. So sin 70 minus 10 will give you sin 60, and sin 60 is root 3 upon 2. Okay, if you look at this question, tan 69 plus tan 66 upon 1 minus tan 69 tan 66 is equal to 1 we have to prove. So isn't this a expanded formula of tan A plus B Okay, so tan a plus b is what? Tan a plus tan b upon 1 minus tan a tan b. Okay, so that is how this is the expanded form. So how can we write in the simplified form? That is tan 69 plus 66 degree. Okay, 69 plus 66 is somewhere around 130. This is 135. Okay, now 135 is equal to minus 1. With the calculator you can check, but how we can mathematically solve it? So 135 can be written as 90 plus 45, isn't it? Okay, and we know that 90 plus 45, the function changes to cot 45. 90 plus theta is in the second quadrant, so tan will be what? Negative. So negative of 45, so minus of 1, because tan 45 is 1. So that is how we proved this one. Okay, similarly, if you see this question, they are asking root 2 cos pi by 4 plus x is equal to cos x minus sin x. We have to prove. Take LHS. Taking LHS, root 2 cos pi by 4 plus x, we can use cos a plus b identity, cos a cos b minus sin a sin b. So root 2 as it is, so cos pi by 4 cos x minus sin pi by 4 sin. Cos pi by 4 is 45 degree. Okay, so cos 45 degree is 1 upon under root 2 cos x minus sin pi by 4 is also 1 upon under root 2 sin x. Take 1 upon under root 2 common from the denominator and it will be cancelled with this root 2 to get cos x minus sin x, and hence proved. Okay, let us come to this question. See, this question is very important, so please try to focus on this question, that how I solve this question with different ways. Okay, you are given if cos a is equal to 1 upon 7 and cos b is equal to 13 upon 14, and a b, they are lying in the first quadrant, which says that the angles will be positive, all the trigonometric functions will be positive. Prove that a minus b is equal to 60 degree. This is the important statement B. So this angle a and this angle b, if we subtract, we should get 60 degree as an answer. So what we are doing here, we need a minus b. So I'm taking the formula of sine a minus b. Okay, you can use cos a minus b also formula, and you can solve throughout, you can solve with that formula, but I'm taking sine a minus b. Let me write somewhat up. So sine a minus b. So what is the identity of sine a minus b? This is sine a cos b minus cos a sin b. This we already know. Now if we see here, we have the value of cos a, so we have this value. We have cos b, we have this value. As in, we don't have this sin a and this sin b, we don't have. Now our challenge is to find the value of sin a and sin b with the help of cos a and this cos b. So you have two procedures of finding this sin a and sin b, and I will explain you both the process, that how we do. So first process is, you have cos a is equal to 1 upon 7, and we know by one identity. Which identity we have? That sin a is equal to under root of 1 minus cos square a. Isn't this sin square theta plus cos square theta equal to 1? Take cos square theta that side. So sin square a theta is equal to 1 minus cos square theta, and you just cancel the square, you will get sin theta equal to under root of 1 minus cos. So that is how I have written here. So you directly put the value. So sin a is equal to under root 1 minus 1 upon 7 the whole square. So sin a is equal to 1 upon 1 minus 1 upon 49. Sin a is equal to 49 minus 1 will give you 48 upon 49. Okay, so in the denominator we will get 7, and numerator under root 48. So for 48, take LCM 24, 12, 2, 6, 2, 3, 3, 1. So pairing should come out. So 2 pairing of 2. So 4 root 3 will be the answer. So this is how we got cos A. From cos A we got sin A like this. Okay, similarly, let us go and just find the sin B, as cos B is what? 13 upon 14. So sin B will be, I'm directly writing 1 minus 13 square upon 14 square. So 14 square minus 13 square upon 14 the square. 14 square is 169, 13 square is 160, 14 square is 196. 13 square is 160. So when you subtract, 196 minus 169, that is 27 upon 14 the square under root. So what will be in the denominator? 14, and 27 under root 27 will give you 3 root 3. 3 root 3. Okay, then we got sin A is equal to 4 root 3 upon 7 and sin B is equal to 3 root 3 upon 14. So this sin A we got as 4 root 3 upon 7 and sin B we got as what? 3 root 3 upon 14. Okay, so this is one method. Now what we have to do, we have to see the other method. As I told you that you can find it by two methods. So now I am going to explain you the alternative method, that how can you find this one. Okay, so see, cos A is given 1 upon 7. We know that what is cos A. Cos A is base upon hypotenuse. Okay, and here also base upon hypotenuse we know. Okay, let us first solve this one, then we will solve here. Cos A. Make a right angled triangle, okay, with A as an angle, because cos A. Base is what? 1. Hypotenuse is what? 7. Okay, and what will be the hypotenuse? Sorry, what will be the perpendicular? Perpendicular will be your hypotenuse square minus base square, under root of hypotenuse square minus base square. Hypotenuse 7 square 49 minus 1 48, under root of 48. And we know what is under root of 48. We just now found that is 4 root 3. So I'm directly writing 4 root 3. You need to just show this by a Pythagoras theorem. We found this one. And what we need? Sin A we need. Sin A is what? Perpendicular upon hypotenuse. So perpendicular is what? 4 root 3 upon hypotenuse. So we got sin A as 4 root 3 upon 7. Okay, so similarly you go for this one. Make a small right angled triangle B as the angle. Base is 13, hypotenuse is 14. What will be the perpendicular? Under root of 14 square minus 13. 14 square 196 minus 169, that will be under root of 27, and that will give you 3 root 3. We need sin B, that is perpendicular upon hypotenuse. Perpendicular is 3 root 3, hypotenuse is what? 14. So finally, by this method also you can find out the other functions. Okay, so all in all, let us substitute the values here in the question and solve it further. So this is 4 root 3 upon 7, okay, into what is cos B? 13 upon 14. Okay, minus cos A. What is cos A? 1 upon 7 into sin B is 3 root 3 upon 14. Now as we have the like fractions here, so let us write 7 into 14. Okay, 13 into 4 will give you 52 and root 3 minus 3 root 3. Okay, now what case we have? Here root 3 is 52 times, here root 3 is 3 times. So 52 times root 3 minus 3 times of root 3, you will get 49 times of root 3. Or else take root 3 common. 52 minus 3 is 49 root 3 upon 7 into 14. You can cancel this with 7 and this 7 with this 2. So we got root 3 upon 2. So sin A minus B is root 3 upon 2. So what can we say from here? This is root 3 upon 2. Root 3 is what? Is this sine 60 degree? Alright. Okay. Now sin A minus B is equal to sine 60 degree. Don't cancel this sine with sine. I told you that we always compare the sine function. So you have to write on comparing the sine function. A minus B is equal to 60 degree. That is the answer. Alright. So this was the last question of the video. Now I will share the question with you. You need to solve the question. I guess I have given you a very good practice of the question with this video. I hope you will understand it better and you will do more and more question and examples. So that's it for today, dear students. Thank you so much.